I want to give a real quick overview of how we deal with rational functions. Now, this is one example of a rational function. And notice what we have here up top, we have a polynomial, x plus 3, and on the bottom we have another polynomial, x minus 1. So I want to show you how we approach just figuring out how this graph looks, just a rough, so that we can get a rough sketch. Here's what we're concerned about. We're concerned about the Y-intercept, X intercepts, maybe one or more or none, and then we want these other things. We want asymptotes. And under the category of asymptotes, we have the horizontal and we have the vertical. I'll do the vertical first. I'll just refer to that as VA. And then we have the horizontal, which I'll refer to that as HA. Now, so this is what we're going to start with. There's also another type of asymptote that we'll look at, but right now, this is what we're concerned about. Now, to find the Y-intercept, just like usual, for all other functions, we let x be 0. So to find the Y-intercept, we just plug in a 0, and if we do, what we get is 0 plus 3 over 0 minus 1, which of course is negative 3. So we have here a Y-intercept of negative 3. So I'll just make a note of that right there. Now, the next thing we want is we want the x-intercepts. So what we do to find the x-intercept is just set the entire function equal to 0. But it's enough to just set the top equal to 0, because if we set the entire function equal to 0, the very first thing we would do is multiply both sides by x minus 1, and what we would get is just the top, the numerator, equal to 0. So, and in fact, whatever makes the numerator 0 makes the whole thing 0. So we'll just do this. X plus 3 equals 0, and we get x equals negative 3. So we have an x-intercept of negative 3. Now, the next thing we want to do is we want to talk about the asymptotes. To find the vertical asymptote, we set the bottom equal to 0. So I'm going to take x minus 1 equal to 0, and I get x equals 1. So now I have a vertical asymptote at x equals 1. So let me just denote it this way. Now, we're going to talk more about the horizontal asymptote in just a second. It's a little more involved. But in this case here, notice that the top, the polynomial at top, so this is a first degree polynomial. Now the bottom, notice it's also first degree. And that means, x to the first power. The leading term there has the power is 1. On the bottom, it's also 1. So we have the degree on the top and the degree on the bottom are the same. So what that means is our horizontal asymptote is just the ratio of those two. In fact, the horizontal asymptote would be y equals 1. 1x over 1x. So now let me just mark that on here. I'll do it with a broken line. Now, we're ready to do a sketch. And the way I like to do these sketches, I like to use the vertical asymptote to divide the plane. So I'm going to look to the right of this vertical asymptote. Now, if I look to the right, I've got to figure out, is the graph going like this, or is it going like this? It's got to be one of those two, because just the nature of asymptotes. So what we're going to do is we're going to try to figure out, well, which one must it be? Well, the only time the graph is going to cross the x-axis is right here at x equals negative 3. So since it doesn't cross anymore, we're thinking, okay, the graph is going to need to look something like this. It's going to need to be above. That way it's asymptotic horizontally to y equals 1 and asymptotic vertically here at x equals 1. So y equals 1, x equals 1. Now, we look to the left of this vertical asymptote and we realize, okay, the graph has got to cross through these 2 points. So it makes sense that the graph would look like this. Okay, now let me look at another example here real quick, just so that we can, from the very beginning, now that we've seen one. Let's just suppose that we have 2x plus 1 over 3x plus 6, something like that. Now remember, the very first thing we do is the y-intercept. And that's going to give us 1/6. So when x is 0, y is 1/6. All I did was put a 0 in for the x. Now we want to get the x-intercept. Okay, so here we go. I set the top equal to 0. I'm going to get x equals -1/2. Now let me go ahead and over here, let me just start putting these things in. Okay, so we've got 0, 1/6. So let me see, I'll just put that right there. And then we've got -1/2. So something right there. So there's our 2 intercepts. Now I need the vertical asymptote. The vertical asymptote, the VA, is going to be 3x plus 6 equals 0, or x equals -2. Okay, so here is the vertical asymptote. Horizontal asymptote. Now here's what we do with the horizontal asymptote. Since the degree on the top is 1, the degree on the bottom is 1, they have the same degrees. We're going to do a ratio of the leading coefficients. So that means it's going to be y equals the top is 2, the bottom is 3. So the y equals 2/3. So y equals 2/3, that's going to be up here. And then, just like before, it's time to connect these. It's time for the graph. There it goes. And then over here, using the same reasoning as before. And there's just kind of a rough sketch. Okay. Now, this is just overall what we do. Now, let's look at another example here. Let's suppose that the degree on the bottom is bigger. So let's look at this example. Let's suppose that we have x plus 1, and down on the bottom, we have x squared minus 4, something like that. Now, we still approach it the same way. Y-intercept, put a 0 in for x's, and we get -1/4. So let me just start putting that here on the graph. Okay, so -1/4, so I guess about right there. Now the x-intercept, we set the top equal to 0. Now you could have more than one x-intercept. We're just keeping it simple right now. And you get x equals -1. So you could end up with a second degree equation up there where you would have to solve it. But so now here's what we get. Now it's time to find the vertical asymptotes. Now remember, to find the vertical asymptotes, we want to take the bottom, set it equal to 0. So this gives me x squared equals 4. It gives me x equals plus or minus 2. So here is one vertical asymptote, and here is the other. Okay, now the horizontal asymptote. Here's the thing about the horizontal asymptote. Notice the degree on the top is less than the degree on the bottom. On the bottom, we have a power of 2, and on the top, we only have a power of 1. So that means the bottom power is bigger. Therefore, the horizontal asymptote is going to be the x-axis. It's going to be 0. So this right here, the x-axis, this is the horizontal asymptote. Okay, now We've found everything we need. So let's see if we can figure out what the graph looks like. First of all, I want to look to the to the right of this asymptote. I want to look over here and see if I can figure out what the graph is doing. Maybe it's up here, or maybe it's down here. Let's see if we can figure it out. The way I'm going to do that is I'm just going to pick a number that's over there, like 100. If I let x be 100, think about what I would have. I would have 100 plus 1 over 100 squared minus 4. Now the top is positive, the bottom is definitely positive, so we have a positive over a positive. So the graph is going to be positive. It's going to be up above. Now we could do the same thing to the left. Way over here, we could say, well, let's pick negative 100. So we have negative 100 plus 1 over negative 100 squared plus 1. Well, the top is negative, but the bottom is positive, so that's a negative, so the graph is down here. Now, let's look in between the two asymptotes, and it's pretty clear that this graph is going to go like this. But what is it going to do after this point, after this intercept? Is it going to go back down, or is it going to continue up to the left? Well, to make that determination, we could pick a point here, like this is negative 1.5. And let's find out if it's positive or negative when we plug into the function. So if I plug in a negative 3/2, and then a negative 3/2 down here, and we'll see if it's positive or negative. Well, the top is going to be, we have 1.5, a negative 1.5 plus 1, that's a negative 1/2 up top. Now down on the bottom, we get 9/4 minus 4. Well, that's negative also. So we have a negative on the top and a negative on the bottom, so it looks like this graph is going to be positive, so it's going to be up like this. So this is kind of an overview of what we need to know about rational functions. There's a lot I haven't said, but this is kind of tells you, this kind of gives you an overview and gives you the bare minimum of what you need to work on these.